Okay, we continue, and it would be another presentation devoted to decision optimization, and our presenter is Tim Varelmann, who is a new generation of experts, belongs to new generation of experts in optimization, and he is the founder of Bluebird Optimization, and his company is trying to bring mathematical optimization to industry, especially in supply chain, logistics, and energy. And many practitioners love to read Tim's posts on LinkedIn. I do. And the most recent focus of Tim is making planning under uncertainty something that the whole operational team can understand and update. And it's not only modeling specialists can do it. So from this perspective, it's exactly what our DecisionCAMP is looking at. Tim, go ahead.
Awesome, thank you. So as Jacob mentioned, I want to fuse two things. The uncertainty part is what Meinhof just introduced us to, which is great. And it's also what I'm working on. And I wanted to fuse what I'm working on with something that I consider an underdog, but it's still important because visualization is the thing that bridges the gap between the PhD folks in machine learning and optimization and the people in the operation room who are responsible for the disposition and logistics, for running our electricity grids, stuff like that. And really, this is a weird time right now because for me, this talk is essentially done, right? I have done the research, created the slides, rehearse the delivery, hopefully in a manner that is not too often, but also not enough. And for you, the talk just started. So I want to share the first story of how this talk came to be and the background of everything that happened so far already. Obviously, the story starts with Jacob's invitation when he asked me to give this talk. And I usually take a stroll after lunch around the neighborhood here. And that's where creative thoughts come to mind. And that was also when I thought, I want some underdog topic. I didn't know what kind of underdog topic, but it didn't take long of thinking afterwards to come up with visualization is the thing. That's how we bridge the gap between domain experts and technical experts. And I wrote down some ideas I had, and I really got the feeling maybe I am too biased. I don't have a well-balanced perspective. So what I did was I asked the audience of my newsletter to share if they had any stories, any experiences to share with visualizations in decision-making technology. And obviously, since I'm an optimization person, that skews still a bit in the optimization direction, but I think it's good enough to give you a bit of a broader perspective. So some of the stories that I got with that outreach, I have included in this talk here. And yeah, I have gotten those responses, and I had an issue that it was way too much. Luckily, I realized what the neighbors in my program are, and initially I thought it would be John and Meinhof. John introduces the topic, and Meinhof then takes care of the probabilistic part, which we have done now in a bit of a different order, so it works out fine. And I can really focus on the visualization part, and in terms of uncertainty, I will only focus on the essentials that I think are important to understand what is going on in the software that I'm building and the parts of the software that I'm showing you pertaining to visualization. So a bit about me. My name is Tim Varelmann. Jacob mentioned I founded Bluebird Optimization with a focus on energy, supply chain, and logistics in terms of industry, and recently in terms of technical things, a focus on decisions under uncertainty. My background is in chemical engineering, so it's always been interdisciplinary for me, always been part of software writing, part of engineering and math, and then process systems engineering was my PhD, where I developed algorithms for the energy transition, so making our electricity grids ready for the future, really. Last summer, I have published an online course. It's called Effortless Modeling in Python with GAMSPy, and it's the first of its kind worldwide, as I see it, really. It teaches the philosophy of how to implement optimization models in a way that it remains maintainable and extensible and scalable, and all the nice things we want from a software engineering perspective in a software. And in optimization, things are a little special, so this course caters to that. Now, this talk will be about visualization. I should add that I have no formal credentials whatsoever about visualization. So really, in the spirit of the DecisionCAMP, this is a practitioner's experience that I'm sharing with you as other practitioners. And as I mentioned, it's augmented by my network. Also, I will have some examples from the software that I'm building. It's called Lucentra. Working with the ideas of Warren Powell, I'm hoping in a midterm to integrate CCAR to it. Meinhof doesn't know yet, but we'll talk about that offline sometime. And the idea is to really orchestrate different technologies of optimization, simulation, machine learning under one hood. And I will show you some examples, some screenshots of what Lucentra is capable of. The general agenda that I have in mind for today is that I have three parts. First of all, I just want to share some war stories from general decision making and how visualizations helped and didn't help. I want to briefly do an excursion into sequential decision analytics. That's the Warren Powell framework for making decisions under uncertainty, which I really like because it's just so powerful and just a unified way of modeling things, which is very important if you want to put things into software. And then once we have those background, of course, I'm going to show you some visualizations in that particular domain as well. With that, the general message that I want to bring across in this talk is that visualization is an underappreciated part of decision technology. When we do decisions, the stakes are high, so you have to have great software in any case. But even if you have great software, it can happen that your users don't use it, and then executives start resenting it because it's just costing you stuff and not really delivering any value. And visually, it looks like this then. That's the difference between something that gathers dust and eventually spider webs versus, as we all know in this audience, I think, decision technology is able to be the most impactful tool in the business when you want to plan, for example, the core business operations. So that's why I think this visualization talk will be quite interesting for you guys. And I'm going to start with the general decision-making case and share some stories that I and others have learned over the part of their careers. Let's start at the beginning. In particular, this starts with a story of mine, my very own beginning. And I want to talk about the 80-20 principle. Whether it's 80-20 or 90-10 or the number doesn't really add up to 100 doesn't really matter. It's a general idea that when you start early on, you get over proportional value realized already. So the first simple steps, sometimes the first 20% of effort can take you to 80% of the benefit. And when I started out, that really happened exactly this way. Right now, I think I have moved along this curve a bit further to the right here. And some of the things I did when I started, I wouldn't do at all anymore right now. Nevertheless, I want to encourage you to just do what you think is good when you want to work with visualization. Everybody has some sort of inert visual intuition, and that will carry you a long way, even if it's just the first beginning of effort, really. I don't want this to become just some sort of motivational talk, though. I have proof, and that is this reference here, which I will give you a bit of time. So that's what Daniel Steinberg, my counterpart at Zalando, gave me as a reference after we finished this first experiment that I did working in visualization for clients. As I said, technically, now I look back and would do many things different, but from his user perspective, he said it was user-friendly, it felt intuitive and intelligently designed. That's all you can really ask for in a reference, right? So the client is happy, even though nowadays I would do something better, something different. I think it's also better, but it's not really said that the users would notice in the first place. Another story is something that did not work. I had a client once where it was very important that they wanted everything to be documented. So we used to have meetings where I would prepare things and I'd say, hey, we have options A, B, and C. Here are the trade-offs. Here is my recommendation. And often the meeting went ahead and people said like, okay, I think we trust your recommendation. The explanations you gave, they sound well thought through. And we'll just go with what you recommend, but make sure that you document everything, because if we want to decide different at some point, then we want documentation of this. And at first I was like, wow, this is an awesome client, you know. I am a developer in many hours of the day, so I know when documentation is sort of an afterthought. As a developer, you're always on the receiving end of that when the documentation is not up to date, not complete. And this company was really making a point to document how they worked and how they wanted to work. So I thought it was awesome. I ended up writing a 40+ pages documentation, and nobody read it. It was total crickets, even though I nudged people to read it, give me feedback, let me know what you think, is this helpful? Couldn't get people to read 40 pages of documentation, even though they explicitly asked for it, remember. However, I had a second shot, and that was introducing visualization. What I did was just annotating some screenshots and adding some captions, you know, a bit of explanatory text, what is going on. And people still didn't read the entire documentation, but they did study and understand the individual screenshots. And here's an example of what I did. I just annotated all the things that you could see here. This was quite a complicated user interface. As you see, the alphabet was not enough. I had Z here, and then I used the German umlaut A to continue some numbers afterwards. But people understood those screenshots. They read the captions and a little bit of essential text that I put close to them. And this really helped as we moved forward in the next meetings. I could feel that people had a better understanding of the software we were building and the iterations we were at and what would be coming next. So that was great. Now, here's the first story from my network, in this case by Harald Mutzke. He told me, Tim, one thing that I can tell you is visual models build trust before they even compute it for a single time. And I think he was very convincing in that. On the left here, you can see a screenshot from Lucentra, the first one in the presentation here. He said, seeing builds trust, and that's exactly where I'm going with this, because I want to cross the bridge between the PhD experts and the operators who have the domain expertise. In this case, this is obviously just a prototype, but the core element that you can see here is a battery. And the battery has some state of charge. As you can see, it's about halfway full. And in this case, we have a model where we have some rooftop photovoltaic plant. As you can see here, we have, if you have high enough resolution at least, we have 3 more or less cloudy days in the beginning of this week. And then we have 4 more days where the sun is really shining and going full throttle, filling up the battery that we have here. And by just rudimentary things, you know, I've used an icon that I like to use for the battery here, but all the other things are just represented as rudimentary plots here so far, because it's just a prototype. And in addition, we have some arrows. That's all we have here, but it really helps to explain to people, as I do for you now, what is going on here. So we mentioned the battery and the PV. We have markets here. If the PV is so high that we have these peaks, we can still sell some of the energy to our grid and get a little bit of money, even though that is not as much compensation as we have to pay if we need to ask the grid to provide us with electricity in order to satisfy the demand, which we can see here on the right. And seeing this model before it even did any computations lets domain experts trust that, okay, in the general sense, this person who is a mathematician and stuff like that, they know what we're talking about here. And that's very important. Also, such a model serves as a shared language, because you can point to things here and really discuss particular things in a way that you couldn't do if you had no visualization to look at, really. Also, Harald pointed out, if you take this further, then you can get a feature, let's say, where if you have some click in the UI, you can generate an entire model behind it. And that's exactly what's going on here as well. So this is a battery that is a reusable component. Behind that is a bunch of equations that I'm not showing to you in this presentation, but rest assured that there are some constraints, you know, just the electrical physics of how a battery charges and discharges and stuff like that. And people who use the UI can simply click, create such a battery, and they have generated all that model that is predefined for them in one click, which is very well. And in this case, I've changed the screenshot as well. So over here now we have an industrial model where we still have PV generation. In this case, it's a bit of a bigger plant. We also have a bigger battery. Probably you can't read that, and it's not necessary to read it. But now we went from kilowatts of the capacity in photovoltaic and kilowatts in the capacity of the battery to megawatts in this industrial setting. But that's just a parameter that this battery has predefined, and we really have a reusable element and tunable parameters that we can use across different models. In this case, we also have different markets here. I've put an intraday market with different prices that vary throughout the day, and maybe you have a reserve auction where you can provide primary balancing reserve to the electricity grid, for example. Just a different market with different market mechanisms. In this case, it's just an auction. But the point is we have reusable elements, and we just define this battery model once, and then we are able to use it across an entire range of applications, really. Another thing, a story of mine, is the limitations of linear forecasting. And what I want to share with you here is the exact visualizations I used to convince a client to actually increase the scope of a project I was working on. So initially, we had a contract for decision intelligence technology that I was building for them. And I realized, okay, we have some forecast that is just a linear regression, and it just doesn't cut it in this case. This was concerning to me because the forecast was out of scope for the contract that we had negotiated. But also I knew that with this poor forecast, it's garbage in, garbage out. There's not much I can do. I wanted to change the forecast, and I said, hey, you either have to hire someone else, I can also do this for you, but this is not included in the scope, so we have to renegotiate, and I'm going to need a new signature from you guys, and I'm going to send you a different bill. And people agreed, but they wouldn't really act on it. And days went by, nothing happened. Weeks went by, still nothing happened, and I lost my patience. And then, once again, visualization came to the rescue. So what you see here is exactly what I took to my clients, obviously now in anonymized form. But I said, hey, we have some feature deviations here and some results on the y-axis. And if we just had business as usual, our linear regression could do it like this. Maybe over here we have a bit of a larger deviation, but that would be tolerable. However, we also have exceptional days where we don't have business as usual. And there, the linear regression actually wants something like this, which would work well for the business as usual, for the exceptional days. But if we want to combine the two things, it would look like this. And then it doesn't work. Over here, we have a large deviation. Over here, we have large deviations too. It's just a crappy forecast, really. I want to develop something non-linear. And then it could look like this, for example. And this is when people started listening really and not just being polite and saying yes, yes. And I said, I mentioned I can do that for you. The idea I have in mind is to use a neural network. And the reason in this particular case is we can mix and match nonlinear parts and linear parts, because obviously there were some linear parts that worked well in general, but we sort of need to put the linearity in some smaller boxes to where we actually have linearization. And a neural network works great for this because we use different activation functions. We can mix and match sigmoid stuff like this one here for the nonlinearities. We have ReLU activation function that provides us with the linear blocks that we need. And then we just let the model train those blue weights here to figure out whatever is going on. And if you have a deep neural network, obviously you can have a new layer of neurons over here. That's beyond the point. This is what I showed to the client. And I told them here we can learn and get the mix and match linear part and nonlinear parts. And eventually, the next day after I showed them this presentation, I got the signature, had the additional sale essentially for the consultant's perspective. And I was able to fix that damn forecast that would lead to the nice optimization I was about to build essentially being unusable. So that was a great experience. Another story came by Jens Peter Jost. He used to work with DHL before he became an independent consultant, and they had to make some change management because they also came up with an optimization solution for assigning parcels to trucks. And they had the issue that the drivers just threw their hands up in the air and said, well, we don't believe this. We don't trust what is going on, and we don't think we can fit the parcels into the trunk of our trucks. The OR team, however, had made sure that they had feasible solutions. And they knew that they could pack the parcels into the truck the way they needed to. They just didn't have visualization. So the missing piece was to build just that, sort of a 3D view and telling the people exactly how to stack the parcels into the trunk of their trucks. And once they had the visualization up and going, everything was easy. Or to quote Peter, the discussion was over. That was very helpful for them too. And finally, I want to share a story from the end of that 80-20 line, because I started with the motivation to say, hey, you know, if you haven't done visualization, just start, because you will get outsized benefits from just starting. I do want to make the point, though, that if you go all the way, that can have its benefits too. And that's where the story from Lucky Data, my client, comes in here. They built a disposition software for the construction industry. You can see a screenshot over here on the left. And they showed this to potential clients and immediately sold the software when they only showed this mock-up demo. There was no real data behind it, no logic that was processed, nothing. Just the design here. But what Lucky Data really did is they went all the way. They hired that external designer to really decide, you know, what kind of color do we want here? How does the orange match the other colors and the green and stuff like that, to come up with this beautiful software. And the clients from the construction industry, they just said, hey, we have software that looks like SAP from the 90s. And it's an issue for us, not just because we want elegant software, but because we have a problem hiring and keeping skilled employees for the dispatchers. People don't want to work with that software anymore because it's just too old and it's not fun to work with. And they bought this software immediately because they saw, hey, with this, we can decrease the churn in our employee turnover. We can maybe even hire more skilled employees. So that's a great decision to make. And again, visualization was the key to achieve that. And for Lucky Data, obviously, this was a great purchase decision. They could sell their software before it was even built already. That brings us to part number 2. As I mentioned, I want to do a short excursion into sequential decision analytics. That is a framework, really, that Warren Powell has developed, and he says it's where the work of his life converged to. Now he's retired and evangelizing for this. He used to be a professor, and he said, as a professor, I had the feeling that there is a jungle of stochastic optimization. So it's just pure chaos. You know, a jungle is more chaotic than the Wild West, I would argue. And he said, there are so many different areas. They all have different names. They also have different naming conventions for the same things and very many overlaps, but you really have to dig deep into the details. It takes a long time to find out which approach differs in what way from the other approaches. And he said, optimal control theory is really what is closest to being a unified theory, but it's not quite there yet. And the changes that he made is what he called sequential decision analytics. And that is just a really theoretical framework so far. It works as a unified way of describing decision-making under uncertainty. So a framework that tells you how to model these things. And what I took on as a task was to build a software that I'm going to show you. As I mentioned, it's called Lucentra, that implements exactly this framework. So here's how sequential decision analytics look. There are 5 basic building blocks. And the first 2 are already on the slide over here. So we have states. For our purposes right now, you can just consider every number that you know for sure as a state. And in the example we have seen earlier from energy, this could be the state of charge of the battery, which literally has state in it. But there are also other states. Every information you have there that you're certain about can be considered a state for now. The second building block are the decisions. In terms of the battery example, this could be, do we charge, do we discharge, or do we leave it as it is in a given time span? And then, because we do optimization under uncertainty, of course, the uncertainty itself has to find its way. And that's the third pillar, the third building block of sequential decision analytics. The fourth one is then a transition function. This is some function that represents the physics, really, in case of batteries of electrical charging, for example. And it just describes how a state at one point in time transfers and the trajectory it takes through time until we reach the next time step, where we again have states, decisions to make, and uncertainties. And then we can put all of these time steps one after the other until we eventually have a time horizon that we feel comfortable with in our simulation. And really that's part of what Warren Powell said is essential for real world problems. One, he said they are always subject to uncertainty. And the second is they are always sequentially decisions that we make over time. So it's not a one-off decision often, but rather you make some decisions, you get new information, a bit of the world moves forward. That's what we see here in the transition state. And then we have new states and we make new decisions based on those new states. And it all starts over again. Right. So here we have the time 0 and then obviously time 1 until we reach the end of our time horizon. Time is a very crucial role in this framework here. The fifth basic building block that we need are objectives. And in real world problems, we always have several objectives. Meinolf mentioned a bit of that in his introduction too. Some examples that we could think of here are economical objectives, such as cost or profit here. We also have softer ones, quality of the product, satisfaction of the client, and maybe also well-being of our employees. We saw that this was important too. The issue is that when we have uncertainty, we have to get rid of the idea of numbers. Meinolf just gave an entire talk about it. If you're looking at YouTube, find Meinolf's talk about this if you want to move to more detail. But the basic idea really is we don't have numbers anymore, but we have distributions. And in case of the profit, for example, we could see here on the y-axis, we have the probability density. And so the most probable profit is exactly this profit down here. And we can have some more profit if things go well, but we will never have profit that is larger than over here. And we can sometimes also have unlucky days. They are not as probable. That's why this number here is decreasing, but it's still possible to have almost up to no profit at all in a given day or week, for example. And because we are working with optimization and uncertainty, and essentially all the numbers are distributions and not numbers anymore, you can always generate twin objectives when you look at risk. So for every of the objective, you can see it say up here, whether that's cost or quality or satisfaction, you can define some risk metrics and you can say, let's look at the average of the 15% worst outcomes, which is the orange outcomes down here under the curve. Or you could have a look at some percentiles and stuff like that, where you want to say, hey, I'm interested in the 90th, 95th percentile, and I want to know how bad things can go if shit hits the fan, so to speak. Those are the 5 basic building blocks that we need for SDA. And if we want to use that, so far we've just taken the building blocks and created a model out of it. Now I want to show you what we do to compute something with this framework. And we take the simulations that we have, so we can start at T1 here and let it run through the time horizon as we've seen on the previous slide. And in the end, we will compute our final objective, the 5th building block that we were interested in. Obviously, we want to do this not just for one scenario. That would be foolish to make a decision based on that, but we want to do it multiple times. And therefore, I want to keep this simple for everybody, but I couldn't resist to introduce a little bit of pseudocode here. I'm going to say, I have a small for loop here. Think of this as simple Python code where I have this sample represented with a dice icon, and I have a list of enough samples that I'm taking those samples from. And so I can go through this loop. I start with one simulation at time 1. I have a particular uncertainty here, so now I can compute how these states evolve with at this point, it's an actual number, not a distribution anymore. And then this just propagates through the entire time steps. And I have, for one particular scenario, one particular objective, one number again. And over the course of this for loop, I end up having multiple objectives that define my distribution in the end. And once I have this for loop, I can now say, hey, I have different policies. I have a bunch of candidate policies. This is, again, a list. And one individual candidate could look like this, where we have different knobs that we could turn and tune. And we use these policies to make decisions. So we take the states, feed them into the policy, and that gives us our decision. Should we charge the battery? Should we discharge? And should we do nothing, for example? And really, in a policy, you could think of anything, any algorithm you like. You could flip a coin. You could take your employees, Alice and Bob, put them into a room, give them maybe an Excel sheet and lock them in until they figure it out. But of course, you could also do something more sophisticated, such as optimization. You could also do a nested simulation inside one. So remember that going from here all the way across is one simulation already. But for this individual step, you can go for a nested simulation if you like, and say, I only have two choices. Should I expedite shipments or not? I just simulate it over some horizon into the future to see how things would play out. And then I decide what is better, expediting shipping or not. So it's totally up to you. This is super flexible. The important point is based on the states that we have, we can make our decisions, and that's what the policy does. And once we've evaluated this for multiple policies, we can just pick the best policy and essentially we are done. Now, that is an awesome and really unified framework for dealing with optimization and uncertainty or decision-making in general, because it's not limited to optimization at all. But we are humans and we don't like uncertainty. What we really want to do is forecasts. So where do forecasts play a role in this framework? Actually, a forecast is something that we do know, and therefore we can put another for loop here if you like, and the forecast will feed into our states. Because right now, if we have a look at the forecast for the weather tomorrow, for example, there is a forecast, it says it's going to rain, I don't know, 10 millimeters, for example. And that is a known number, therefore it's a state. And that also is a way in which the forecast can influence the policy in some way, likely in the way that Meinolf just recommended in his nice talk we saw earlier. If you do it right, at least. So in one sentence, sequential decision analytics is a great unified tool because I think it orchestrates multiple technologies together, whether it's optimization, simulation, machine learning, or forecasting. We can put all of them together, orchestrate them, and really make sure they work well together in a way that works. And the final component that is very important and is really enabled with this, because the computer takes care of all of the grunt work first, and then the humans can have a look at the results with the visualizations we're going to see and do their strategic trade-offs with it. So my message is, again, orchestrating all these different tools in a valuable manner. You can do it hallucination-free if you do it well on the machine learning part, and just use your data in the best possible way to make your decisions. And now let's move to the third part and see how Lucentra can achieve this and what the visualizations are that we use inside of Lucentra. Coming back to the first example I showed you, this is the residential battery. And what you see already on the screen here is that we can make this replay specific scenarios. So the state of charge of the battery evolves over time. In the beginning here, we have some nighttime where the battery is discharged, and then the sun comes up. We see a rapid increase. The battery becomes green because it has larger than 50% state of charge, and then the loop resets here. This is to show you that we can use the model that we already had and we have used to talk to the domain experts even before we had any results. And with the very same visualization, we can now make it interactive and we can replay individual scenarios. If your screen is large enough, down here at the bottom, you might be able to see that you can select different scenarios. If you can't see it, that's fine. You just have to believe me. So if you know that scenario 17 is one where you have an entire week that is super cloudy and just shitty weather, you will not have much PV generation and therefore likely to satisfy your demand, the cost will be high. That's an example that a human can look at and see how bad things get in that particular scenario. Also, you maybe know that scenario 43 is a particularly sunny day and you can look at the other side of things. So that's really useful. And yeah, we can look at the scenarios again. Users watch their particular operations, whatever they want to look at. And one idea that I have stolen essentially from the book, The Decision Factory by John and Adam, is the idea of a Pareto explorer. So I used the Pareto front to show multiple objectives to clients also, but this book put a nice twist on it. Let's have a look at the Pareto front here. So we have two objectives. In this case, I decided to use service and expected cost here. And where we want to be is low cost. So we want to be as far left as possible, and high service. So up here is where we actually want to be. But real world has it that we have to make trade-offs. And therefore, this is what is actually achievable. Very important information for executives to see this again, the computers do the grunt work, and then the executives can see where on this curve they want to be. That's a strategic decision for them to make. Sometimes you can also see, I've seen this, for example, in inventory optimization with Meinolf, where we used Zika, that you have kinks in there. So maybe sometimes this goes up and then it levels down for a bit. And sometimes people might say this is a sweet spot here because we don't have to increase our cost, and if we were, the service level wouldn't go up much. And again, it's a strategic trade-off. Sometimes you might say, hey, this is an awesome thing. It gives us the best bang for the buck. That's exactly where we're going to place our operations. But sometimes you might say, hey, we are actually some premium company. That's not enough of a service level. We really need to go all the way over here. But at least this is a way that informs executives about what is possible given the uncertainties we can expect from whatever we have sampled, either from history or from other distributions, really. And it really allows people to interact with these multiple objectives. The nice idea that I've taken from this book is that you can make this interactive too. And you could select one solution and then show it over multiple Pareto plots. So let's add a second plot. You might remember that I mentioned we can always generate a risk measure from a given cost objective, for example. So that's exactly what I have here. And in this case, we actually want to be down here. We want the worst days to be sort of okay-ish. And of course, always our interest is to reduce the costs. So we want to be down here really. Again, we can't. These are the realistic options that we can achieve. And the nice thing that the idea that is promoted in the Decision Factory is, hey, visualize them all together. And if you select one solution here, you can see exactly how the service level behaves as well if you put all these plots together. And that's a new idea that I liked very much and that I put into practice. And that's what you can see here. Again, you have to believe me when I say if you have a screen that's not big enough, but what is going on here is you can see that we have a bunch of Pareto fronts here with 3 different points on them. And on the screenshot I took here, or the screen video, is a cursor moving around. And if this cursor hovers over a point, it selects that point and marks it in orange in all of the other plots too, so you can see really what's going on. And I put a twist on that and said, hey, I actually want to be able to select something with a click. And if you click on some solution, then it is marked in a blue ring so that you can see what is selected and what you are hovering over right now. You can really make comparisons of the solutions that are available across multiple objectives in this way very nicely. Again, there's one issue, and that is already here. This is quite hard to see what is going on. You have to be quite familiar with the domain and really see this same plot every day in order to be able to use those 6 plots and make sense of it. And it's not like sometimes we have even more objectives. So if that is the case, again, the tip that I got from Harald is parallel coordinates. So in this case, I have chosen to visualize 7 different objectives. And you can put them here and sort of have one line showing how the solution that you have works out with respect to all the different objectives that you have. I personally find it really important to use colors well. So over here, you can look at one objective in the focus because it's orange, and all the others are sort of dimmed into the background with a gray color. That is important because otherwise you're very quickly not able to see anything anymore. And there's also a nice twist that I found once I researched this idea, and that is you can put a little bit of correlation of the objectives into the picture. So let me move back and forth to see what is going on for you over here on the right-hand side. This is an equidistant grid, and you can move the objectives that are closely correlated together a bit closer, and then those objectives that are less correlated, they have larger distance between them. Obviously, this only works for the pairwise correlations between neighboring objectives in this way of visualizing things. There is no way to say how profit and quality or satisfaction are correlated this way, but you have to pick some order first, and then you can do this, which is a nice addition for these parallel coordinates. And it makes sense that you have profit, for example, over here, which is closely correlated to turnover, and hopefully less correlated, but still correlated to cost. Because if your profit depends more on the turnover than the cost, then your business is healthy, you know. Again, quality and satisfaction might be correlated, and well-being sort of on its own sort of doing what it wants really in terms of correlation. And obviously, we've heard Meinolf, who also replied to my outreach to my network and said, you have to show the distributions. That's how people make decisions. And just a simple example that I want to show again, you might have two policies that have two outcomes. Policy A is rather predictable. We have lots of probability around here that this is the result we can achieve. There is some variance in it, but maybe we want actually policy B. Policy B on average gives us lower cost, for example, but it has a long, expensive tail. So if things go bad, then B can become really expensive, whereas for policy A, the costs are somewhat capped. And again, I think the computers have to do the groundwork first, and then we visualize everything for either the executives or the people in the operating room who have the domain expertise to make the call with a human strategic decision. Of course, we have Seeker available that Meinolf has produced and given to the world, which can do this very nicely and out of the box already also. This is very nice. I've used it in the past. And I've also integrated that idea into Lucentra, where you have not just visualizations of objectives, but you can also run through the entire thing and say, hey, all the things that have a name in the model, essentially, I can create such a column for. Over here, I've chosen the state of charge of the battery. Another column shows the PV generation, the photovoltaic. And here we see the energy spill that we have. And then you can add some rows also dynamically, where you have a baseline policy and maybe a more aggressive policy. And you can see over here that for the state of charge, it doesn't make much of a difference. For the PV generation, that is obviously completely oblivious to whatever policy we choose, because that's pure uncertainty. But over here, the energy spill is something that we can actually influence. And we have a huge peak over here that happens when we do the aggressive policy, whereas if we sort of do it more baseline, that doesn't happen. And that's the price we have to pay for being more aggressive, let's say. I want to conclude with a little overview of the things that I hope to achieve with Lucentra once it goes from prototype over to a done product, let's say. We mentioned that it orchestrates different technologies in a nice way. I have shown you a bunch of visualizations that we can use both for objectives and distributions. And also we've seen that we can visualize the model before it's done any computations. And once it's done any computations, we can replay them too and make them visible to humans, how the time evolves really. And what I, as a software engineer, also like is the model managing capabilities. We can define reusable cores, such as the battery, and then take that same battery and put it either in a residential environment, or we can put it in an industrial environment. We can compare different models under uncertainty. We can also compare different policies, obviously. And we have administration, how to store the models, how to store the model results that we have computed once, so that maybe in the future we have another idea for another experimental error we might want to try, and we don't have to compute the baseline again because we can just simply store it. Going back to my core message, I hope I've convinced you and shown you a bunch of examples how visualization can make the difference between having great decision technology software, either gathering dust and spider webs on one hand, or actually becoming the most impactful tool that a business has. That would be a great thing to achieve. Again, this is a practitioner-to-practitioner talk. I'm looking forward to your feedback and your stories about visualization, because I'm sure there are many more out there. And send me an email if you like. Otherwise, there are also other ways to reach me. Here's a link to my online course. Again, this is about the philosophy of how to write, implement easy to maintain, easy to extend, and easy to scale models in optimization. If you care to read Bluebird briefings, that's my very own newsletter. Maybe next year I'll hold a different presentation and you can provide input there as well if things go again the same way. And obviously, if you're interested in having me as a consultant, I'm not a consultant like BCG or McKinsey consultants who just give you a nice PowerPoint presentation. Once I have consulted you, I can also architect and develop software for you and like to do that. So if you want, pick a time slot on my calendar and we can talk. Thanks a lot.
Okay. Thank you, Tim. A very good presentation. And It, by the way, confirms that what people in this industry who worked for many years actually did a lot of similar things, and probably Helmut or other people closer to my age can confirm this. Visualization helped us always to win projects, and we actually usually started with visualization, and this is a very good point, but you brought a lot of new methods, and this is really good. And we have questions. You can look on the chat. Go ahead, Helmut.
Okay, very nice talk. Enjoyed that. I do have a question on the parallel coordinates. I always struggle that the scaling of the individual coordinates is kind of data dependent, and it's not kind of immediately obvious to a user to see what the range of values actually mean, whether two things that are spread out over the whole coordinate range actually are quite close together, or whether they are really meaning things are quite different. So you have any hint, any advice on how to do the scaling on the individual coordinates? It's a very technical question.
Yeah, but I don't have a silver bullet, unfortunately. No, I think it comes down to trying different things. Obviously, getting feedback from users is very important. That's what I found. If I'm not sure with these kind of things, I prepare like 3 options and say them, hey, this is how each of the options look like. What gives you the most benefit for the particular decisions you are making in your day-to-day operations? And that typically gives me an answer that people can live with. But obviously, that's not a general answer to the question. No.
Okay. More questions? Okay. Mainolf.
Well, I mean, so there's 2 ways to go about it, right? I mean, what Helmut is saying is essentially recognizing that multi-objective optimization is undefined or ill-defined, in that you don't actually know what the relative scale of each objective is. So if the user has an idea of what is fair and what's excellent, that gives you some form of a scale. Lacking that, you can simply look at your portfolio of of solutions, and you have a range for each one of them, right? So call 0 what the worst one is, and call 1 what the largest one is, and that gives you your 0 to 100% in your visualization. That's the alternative. It's just that in one objective, all of them might solidly fall into completely acceptable ranges, so that people aren't concerned with it at all. And in that case, it's kind of silly to have it in there in the first place. But that's a way around it.
Yeah, like essentially what you mentioned is you can either do the relative thing or the absolute thing, and it depends what you want, right? Sometimes you also, this is a classic lying with numbers thing by cutting off the 0 essentially, because if you don't really have much variation and you cut off the 0, you can always fabricate large differences, which you obviously don't want. And what I've also seen is sometimes clients want, obviously, different objectives can have different units of measure, right?
Yes.
All the economic things are typically measured in dollars, and sometimes you have different cost components, and they want them all on the same scale, whereas the profit obviously has a completely different order of magnitude, so they want a different scale for that. And there you also have some relationships between them that sometimes they want in their visualization. But again, you can, for me, I found the easiest way to find this out is show people what you have in mind. And if they want this kind of customized thing where some things have a relationship, they will tell you once they see some of the examples, even if you don't include it, they will tell you, okay, I see this is kind of good in this way and this is kind of good in that way. But I'm looking for like a compromise. Can we achieve that? So getting people talk always helps.
Okay. Tim, again, thank you very much. And that was a great presentation.